Hey, manufacturing world, welcome to another episode of Shop Matters. I'm Wade Anderson, your host for today's episode, and this is something a little bit special to me. This is the first time I've been able to record a podcast on the road. So, Denny Arcus, if you're listening, beware, because I have microphones and will travel. I may show up on your door someday. So, today I'm recording from my friends at Big Kaiser in their showroom here in Big Kaiser in Illinois. So, I want to thank you guys for letting me come into your place here and make a makeshift studio.
You're very welcome, and glad you could make the trip to Chicago, and I'm glad that this is your first experience out, and you picked us.
Right.
That's really appreciated, and Chicago's a great city to come to.
Absolutely. So let's do a quick round of introductions. Nick, tell us a little bit about yourself.
Sure. My name is Nick Jew, Research and Development Engineer here at Big Kaiser. I work on a lot of new products, new developments, as well as machining works down in here in our showroom.
So you're the brain power of Big Kaiser.
I guess so. I don't really know.
Yes, he is.
Yeah. Jack, tell the world who you are.
Hey, thanks. Jack Burley. I'm president of Big Kaiser. I've been with the company for over 30 years now, so I've grown through it from engineering, like Nick, maybe not to his skill, but through the sales, marketing a little bit, and now I'm, I guess, running the show. So, yeah.
Fantastic. So you've been in the industry a long time. You started when you were 12?
Not quite 12. Yeah, I think I was 16. No, it's been an interesting journey. Yeah, I started on the old manual drafting boards as a design engineer and just worked up through. And I liked a lot of the going out and meeting people and getting interactive on the machining side, so solving problems. And that was more my forte, you know. It's like applying the tools, not so much designing. Design was fun, right, and it certainly wasn't as fun when you didn't have an AutoCAD or SolidWorks behind you, but it was fun, and it's always a great tool that I rely on still today. You know, I think a good tooling or machine tool person has some expertise in engineering to fall back on to talk to customers.
Yeah. You know, I think there's a lot of people, yourself, myself, we started out in a machine shop. We ran machines, but then over time you find that you really enjoy dealing with people, and I think that's one of the things that once somebody gets to working for the OEM, like an OEM machine tool builder or a supplier, once you get a taste of that, it's hard to go back, you know, different directions. So.
That's for sure. A lot of people have tried to leave, and one way or another, they seem to come back.
Right.
You know, you think you've seen the last of somebody, and 5 years later, here they are. It's because I just couldn't get away from it. It's just too much fun.
And you get to see so many different projects, so many different applications. You see so many different customers. And even if you see 5 shops that are making similar parts, all 5 of them experience different problems, need different solutions. So to me, in this type of a role, your brain is constantly working. You're always trying to come up with new solutions, new ways to solve problems for customers, and keeps it exciting.
Oh, and I totally agree with that. And, you know, you always got to keep an open mind. As we get older, you start to think, well, I know more than everybody. You don't. And you'll learn from somebody young like Nick on something that you wouldn't have thought of, because they're approaching it from a different side than we ever did, and that's how we all learn. So you got to keep an open mind, open ears, open eyes, and, yeah, you go into the customers, and you might see something in the back of the shop that, I don't know how this escaped me all these years, but that is an interesting thing that they're doing over there.
Yeah. Anybody that's heard me talk, or I've probably said it before on podcasts, but knowledge has a shelf life. You know, you can have a lot of knowledge, and that's got a lot of value for a certain period of time, and then technology or somebody's new idea is gonna leapfrog it. And if you don't stay immersed in what's taking place in the industry, all of a sudden technology passes you by, and what was once valuable to you now has become a commodity. It's not nearly as important.
I totally agree with that. And I think inherently we have to have a certain amount of curiosity. Yeah. That's what drives us, you know, to say, I'm curious to know how that works. I'm curious to know how to do that better. And the curiosity of us, or the curious part of us, drives that innovation. Mm-hmm. And that's what I try to push down to everybody is, you know, this is how we can do it, but be creative. See if there's a better way that maybe we haven't thought of. And our engineers in Japan and Switzerland, they're relying on us, the people out on the street, or so to speak, to find out what is the customer's pain points and how do we improve it.
Right. The innovation, that's something that I've always thought is very interesting, because it takes somebody that's got a little bit of fire in their gut to look at something and go, I can do that better. What they're doing is cool, but if I tweak it here, if I add this, if I change that, I can make it better. And then that just builds on each other, and you get that kind of a compound effect over time.
And I think the better ideas aren't ego-driven. Not so
good
much
point.
about being, hey, I did this better, look at me. No, they just wanted to see if they could do it better.
Yeah.
They weren't out to prove a point.
Right. A lot of innovation happens by accident.
Yeah. I don't know if Henry Ford believes that, but
Very good. So, Nick, how long have you been with the company? How long have you been with Big Kaiser?
So mine's a little interesting because I've been with Big Kaiser as a full-time employee for about 3 years now.
Okay.
However, I was actually a summer intern for the past 4 years before that. Right out of high school, I became an intern here for the summertime, and every summer I just kept coming back, and then Jack and all of the other upper management wanted to take me on full-time.
Jack locked you in a corner, wouldn't let you leave, huh?
I don't think about it that way.
well, they say develop your talent from an early age and keep your talent and keep them driven and keep them focused. Mm-hmm. And, of course, we had an idea. Hey, we got this young kid out of high school coming in. Well, let's just give him this little project. He sounds like he's pretty smart, but it'll take him all summer. 2 weeks later, he shows up with a completed solution that our engineers probably would have had a hard time doing. It's like, okay, now what do we do for the rest of the summer? So,
Got to keep him busy.
He's very sharp, and he makes things look too easy for the rest of us.
Oh, nice. Excellent. So tell me about some projects that you've worked on. What's some cool things that you've been working on?
Sure. So like as an intern, I started with actually working with our products, mainly in the presetter lines, created a new software for some presetters that we were testing with and trying to make a better solution for customers to improve their workflows. Okay. So I worked on building a new software for that. I also developed some prototyping drawers and stuff like that for our Russo benches and kind of like all these little electronic things. My background for college was electrical engineering. Okay. So I kind of had that different approach to it. I actually never was a machinist before that. I didn't have any experience with CNC machining or anything mechanical. But being here as an intern, I got to see the machines a lot and got to see what you can create with a CNC machine. And that's what drove my curiosity into more the mechanical side, even though I graduated with an electrical engineering degree and a software minor.
Okay.
So I have that as my education, but the machining side, the hands-on stuff, is the stuff that really draws my attention to.
Yeah. And I find that a lot of creative people, once you start working, you're doing stuff with your hands and creating things, mm-hmm. it just creates that energy, and you want to do more and uncover more and develop new stuff. So.
Oh, definitely. And I mean, as a kid, I always loved taking apart things and putting them back together. So I've always had that in the back of my mind to be able to do hands-on things like that.
So you were the one taking your dad's radio apart? And
well, I was probably the one fixing it whenever something was going wrong.
Gotcha. So Jack, I kind of leapfrogged. I automatically want to get into products and what do you do, but let's talk about Big Kaiser and who is Big Kaiser for people listening that aren't familiar with your products. Growing up in the industry, I've always been synonymous with Big Kaiser and the Big Plus tooling. You guys do a lot more than that. So tell me just a little bit about Big Kaiser in general.
Yeah, Big Kaiser is a subsidiary company of Big Daishowa from Japan near Osaka. And they are about a 45-year-old company. They started in the business for tooling systems. They're growing. They had some key license products that they brought into Japan. One of those products was the Kaiser. And that's where the Big Daishowa and the Kaiser merge came in. And it's been known as Big Kaiser is because in Japan, they promoted the Kaiser boring tools from Switzerland as Big Kaiser. And when we got associated or affiliated or working with Big Daishowa here in the United States in 2003, we kind of said, that's a nice name. And they wanted to come into the United States with some buy-in, if I could say that, to the market, not just as another company representing them like they were before. So there was some buy-in to our company, which eventually ended up being now 100% where it's at today. And we still represent all the Kaiser boring, which is still known as the Big Kaiser, which is the trademark items. And then we have all the tooling systems made by Big Daishowa. And humbly speaking, I like to say this, that they are probably the largest tool holder and collet producer in the world of the class of product that they make. I'm not going to say they're number one by volume and numbers of tool holders they produce. They do produce 500,000 tool holders a year and 30 or 40,000 collets a month, but at a very, very high level accuracy. And that's very, very unique. And they don't do that with just 50 or 60 different line items. They do that with tens of thousands of different product lines. When you take a collet chuck with a Big Plus Cat 50 interface, I mean, you're already talking just for one ER32, 4 gauge lengths. And then you got all the other ER sizes, and then you got all the other interface sizes, and you got HSK and Capto that we make, and you start to multiply these numbers of families. It's a lot of varieties. And when you look at somebody tooling up a machine, usually you need 40, 50 tools to do that. You can get by with 20, but you might even need 300. And they need them right away, because tooling is not always the first thing that they think about when they buy a machine, but they don't always put that on the front end when they're looking at that. So they rely on our inventory. Right. And they have an incredible inventory of all these different products in Japan, which we also carry here in the United States. We have shipments from Japan all the time. And to help support that, as well as what we get from Switzerland, we have some licensed production here in the United States too, because a lot of that's a fairly basic product that we can still support and make ourselves. So we're a competent company in fine boring from the Kaiser boring side. We've been in that field for 60 plus years, and I really like to, again, humbly say that I think we're one of the leaders when it comes to boring tools. Right. We've got a lot of legacy products. We were one of the original companies that equipped all the SIP and Dixie machines that were ever sold all over the world.
Oh, no kidding. Wow.
And these products were copied, or tried to be copied. And that experience they've drawn on. And now we're into the digital age, and guys like Nick are able to take up some of these challenges of going from what we were as a mechanical company to more of a electromechanical focused company, because now you got to put the two together. We hadn't done that before 5 years ago, and so we're doing that ourselves. Okay. Kaiser in Switzerland is not outsourcing this because we don't have the competency to do it, so we'll just have somebody else and we'll put our name on it. No, that's not how our companies work. They are very vertically aligned to produce it all and design it and develop it all themselves. So they get into other stuff that most people wouldn't associate. They have a full electronics department in Japan where they produce a lot of vision systems and touch-off probes and a leveling device. And most people wouldn't think, you guys make a leveling device. Yes, we actually make that and designed it ourselves.
No kidding. Wow.
Yeah.
That's incredible.
So they're very diverse and very large. They got 7 different factories running in production, highly automated, and not as many workers as you'd think is for the amount of work that's coming out of it.
Right. So I had the pleasure here, what was that, 2018?
Yes, it was.
We did a tech tour, and I took a group of customers throughout Okuma. I got to be the kind of host from the Okuma side, and we went from Okuma and went to Big Kaiser. We stopped in Osaka, went to that's where the headquarters is.
That's correct.
And then went down to Iwaji Island where a lot of the manufacturing is. And it's pretty incredible when you walk in and you see rows of spindles, all these machines, and every one of them, or it might have been, was it 2 to 1, 2 machines in one row, but I can't remember now off the top of my head, but just an amazing amount of automation taking place. And to see that much manufacturing on an island in Japan and high-tech equipment, fully automated. I mean, it's truly what manufacturers in the NTMA group that we took there, that's what we want to show them, is what's the future of manufacturing? What are people in other areas doing to be more efficient, more profitable?
Well, that's an interesting story about why they settled on Iwaji Island, which is up until they built the Takashi Bridge, there was no way to get to it except for driving all the way around the main island to get to it from the other side or taking a ferry boat. But the owner, the president of the company, he was from Iwaji, and it's like a farm area. Okay. That's where the Kobe beef is grown, and that's where that wide widely known, famous beef is made on Iwaji Island. But he
Which
grew
is
up there.
fantastic, by the way.
Yeah, it's like butter. No, and they got into the point at Osaka. They had one plant there that they were growing, and literally BIG comes from their vision as a company. When they started, they wanted to be a big company someday. It's not any Japanese word behind it. It just means English. They want to be a big company, and they quickly outgrew Osaka. And if you've been to Osaka, you remember it's landlocked. There's nowhere to go but up, or by somebody, and that's very expensive. And our president at the time, Mr. Khomeini, he said, this is back in the early 80s, I grew up on Iwaji Island. What if we had the opportunity to build a plant over there and staff it and do it without any preconceived ideas of how to do things?
Nice.
So he took literally farm boys, young guys, and I hope this doesn't go over there and they take this the wrong way, but he took fairly educated, well-educated, from high school and some basic trade schools. And he said, we're going to do this our way. Don't look at what everybody else is trying to do. And they developed these factories, which were highly automated. And to them, they ingrained it from a very early start. We deal in less than 5 microns. That went down to less than 3 microns in everything we produce. So it became natural to them that this is normal for us. Right. 3 microns is our normal.
It's not difficult. That's the normal.
Right. So when you achieve that kind of look, that you want to be that good and don't have another expectation that's much easier, you don't always say, oh, man, we're always trying to hold these tight tolerances and things like that. So they kind of left all that behind, and they were able to grow that culture from zero.
Wow.
And it's still there today. And everything they do is with the highest pride and precision. Every product is inspected completely, and they are very meticulous on every little detail. If you look at chamfers or you put a collet in your hand and you feel it, it's not sharp. You can rub it around in your hand, and you're not going to get any little nicks or edges that can cut into you from those slits. And that pride, milling features that don't need to be milled. But at the end of the day, customers are buying high precision products. They want it to come out of the box, which is a quality looking piece of packaging, and it looks like, hey, this was worth the money.
Yeah.
And this is a high quality looking product. Other companies are trying to duplicate that with, you can make a shiny looking part, but at the end of the day, you still have to have that precision under it. You can't just hard turn things and say, look at how good it looks. Yeah, it looks good, but you have to have that precision. And one of the things they're known for is the surface finish on their tapers.
Right.
They are right there with every single one, as good as any spindle ever built.
Yeah, that's incredible. So let's talk a little bit from a quality standpoint, because from an Okuma perspective, we've seen some service issues at times with products where I'm leading to this is the Big Plus spindles. So there's the Big Plus. All of our mills come in standard with a Big Plus taper on it, but a lot of times you'll hear dual contact tool holders, and there's a difference, right, in how it's measured and the quality that goes into it. So let's kind of peel the layer on what is Big Plus when we talk about that. What does that mean? And then what are the problems that can happen if somebody buys a dual contact taper but it's out of spec?
Yeah, that Big Plus is a dual contact system where we rely on taper and face contact simultaneously. And that's not what our patents were about back in the early 90s when we developed it. And I'll talk about that in a second, but it just achieves higher rigidity because you have a much larger contact zone than once you get off just a standard steep taper to spindle contact. And there's other companies before us that have done dual contact, but those previous designs always left the gauge line of the spindle face where it is. So, normally the gauge face or the gauge line is at the face of the spindle. And that dimension can float plus or minus 5 thousandths either direction because it doesn't really normally matter. And so to make a dual contact system off of that gauge plane, you, of course, add all that material to the tool holder, 1/8 of an inch or whatever that would be, and grind it to fit. And because that now is built to that gauge plane, I can't take that tool holder anymore and put it on a different machine because it might interfere with the face. because it might be in a different or wrong location. So you're kind of mirroring these tool holders to machines. And while that works okay in a non-commercial environment, how could we make something commercial? So Big Plus, the whole concept and the patents were written around interchangeability, that let's just move that gauge plane out half of the normal distance of that gap, and then make up the other difference with the Big Plus tool holder, so that I can now put a Big Plus tool holder into any spindle ever made without interfering or achieving dual contact when I have a Big Plus spindle, and vice versa, right? I can take Big Plus spindles, and I can accept standard tool holders without interfering when I don't want it to. And so that concept that, hey, you don't have to go down the road of Big Plus. Japan likes a lot of their BT and steep taper tooling. They wanted to improve on it. But this is a way to segue into dual contact without making big changes to HSK or Big Capto or something like that, because you had now the choice. And companies like Okuma, they were brought in on how to use the license and get the gauges, and it's really simple. All you have to do is add some material to your fascia spindles, and we're going to qualify with our gauge where that goes. And they took an early decision, Okuma did. It said, why don't we just grind everything this way? Make that final part of the piece, and then we'll give that over to sales and marketing, and they'll decide how they want to do this. And for years, I think they just kept grinding them, but weren't actually promoting them. So as Big Plus now is out there as a de facto standard, I call it, it's not an industry standard, so you can't call up ISO or ASME or DIN and somebody says, give me the spec on Big Plus. It just doesn't exist.
Right.
So because these are fairly critical tolerances, and you have to reverse engineer it if you're a copier of it, you don't know what these tolerances need to be and what those gauges really should look like to do this properly. And for this to work properly, of course, we work on elastic deformation of the spindle during clamping, which is not very much. On a Okuma machine, for example, it might be 0.5 thousandths or 0.8 total.
Okay.
And that's the amount of elastic range that we deal with to make sure that we get the taper contact and the face contact, and that you can buy any one of our Big Plus tool holders and put it on any Big Plus spindle and achieve that accuracy.
Right.
And we have very specific and known licensees that we work with that can build Big Plus tools. And arguably everyone has come back and said, this isn't easy. But it is possible. And once you get it dialed in, it does work. So it's very important that you use the gauges and we get it right, because it's a small window.
Right. So one of the problems that can come up if that is not correct is you get the face contact, but you don't have good contact in the taper. So now you've got this tool floating around inside the taper. So we've seen experiences like that where we've had spindles that get fretting up inside the taper. And of course, people will point to Okuma. It's our spindle, it's our taper. But then you go in, and that's one of the first things we do is we'll take the customer's tool holders and we'll start inspecting the tool holders and find out that they're not in spec.
And the easiest way to determine whether you're getting that bad fit that direction, because once it goes in the spindle, you're closing up that face. You can't really determine. You can't wiggle it around or anything.
You can't see it, right?
Check the runout, and that's what I use as an indicator. Is say put a gauge pin in a really quality collet check or something, like check your runout, and usually it's going to be like over 1,000ths or maybe even 2,000ths. That is like alarms.
Yeah, that's red
wrong.
flags.
Yeah, definitely. It's not connecting on the taper, and we usually see that with the wrong or not made properly tool holders from somebody else. But if a spindle goes through a grinding process where they didn't qualify that face again, that can be another problem too.
Okay,
yeah.
So they regrind a taper, machine's been wrecked or something like that. They send
Forget
it out
about
to
the
a rebuilder. That makes sense. I could see that. They grind the taper and forget about the face on it. Yeah.
So the runout's the easy one. And the other thing I've suggested to people, if they're not sure, is take the pull stud off and just try to push it up in by hand. And when you push it up there, you should still see a small light gap of like 0.5 thousandths to 1,000ths. And that's the elastic draw I was talking about.
That's when the Belleville washer or whatever your drawbar is pulling it into the spindle.
Going to pull that up in there. It's going to elastically move that taper wall a little bit and suck it up till the faces connect, and that's how it all works.
Okay.
And in essence, when you do use the dual contact right in a Big Plus system, it acts like a stopper. And over time, you're going to see that the spindle doesn't degrade out of its tolerances as quickly as one that doesn't have it. Over time, a steep tapered spindle that doesn't have any kind of a dual contact to it, it's going to keep elastically and then more bell mouth out of tolerance completely, and you start seeing a lot of improper taper fit. And it's basically like wearing in a shoe to your foot. Over time it just happens, and the machine and the tools adjust. But now if you take a tool out of a different spindle or try to introduce a dual contact at that point, a new tool, it's not going to work because the bell mouth and all that's in the wrong place.
Right. That makes sense.
Yeah.
Very cool. So let's talk about some new products. What do you guys have new coming down the pipeline that customers should be looking for from Big Kaiser?
Sure. So the first thing I guess we can talk about is boring applications. As of now, Big Kaiser, we have our digital boring heads, which have Bluetooth capability. You can read the current position of the adjustment from your phone or tablet. But the next iteration of that would be to make that fully automated. So instead of manually adjusting a boring head, you just type it on your phone, just adjust by a couple thousandths, and then it'll just move to that point and lock it in place, and then you run it. So
very cool.
That is what our next product is. It's our automatic boring bar or boring head.
Okay.
And with that, there's a whole bunch of different technologies that need to be added. There's so much motor technologies, electronics, battery power too, since we don't have it connected to any spindle powers. We're using it all isolated in the tool itself. Then there's also the communication. Right now, you could connect with your phone or tablet using Bluetooth, as I mentioned before. But in the end, in an automated cell, you would want to have the machine control, kind of do all this commands itself. Measure the
handshaking between the two.
Exactly, and like use a touch probe or bore gauge inside the machine to measure your bore. Make the head, okay, you need to adjust out by a couple thousandths, and then it rebores it and then checks again. And if it's qualified, then you move on to the next part. And that could be all automated if the boring head is able to make these adjustments automatically.
Okay, very nice. So I got to see, I think it was probably one of the prototypes. Was it EMO? Backing up my memory here.
Could have been a couple places.
Yeah.
EMO right before the EMO before the pandemic, I guess we could say.
Yeah.
So yeah.
Yeah. So we have that in the line, and I guess going with that, working with an Okuma machine, since we have one here now in the showroom permanently, doing that integration was so straightforward because we can actually put our software that controls the boring head directly on the Okuma OSP control. Since it's a Windows-based computer, we can put it in there, and it was very streamlined on connecting it, and we actually have it fully integrated now on this machine.
Very nice. That's one thing I've talked a lot about with people over the years, is that OSP control, literally, if you can do it on a desktop or laptop computer, chances are you're going to be able to do it on that control. Mm-hmm. So that really opens up the window of imagination of what you can do. If you can envision something communicating from your phone to a laptop, chances are you can do that with the control.
Yeah, and it's so user-friendly too.
Yeah.
And I guess as an example, I didn't actually develop the software that controls our automatic boring head here. We actually developed it in Switzerland.
Okay.
And our Switzerland team doesn't have an Okuma available to test it on, so they just kept creating the app. They sent it to me, and I did all the testing here. And even though it's like that disconnect of I don't have a software developer right next to me to diagnose the issues, we didn't have any issues. It was just the first time we added the API libraries in, we did a few tests here and there, and then it just works. Okay. So being able to use the Okuma control like this, where it feels like just a standard computer, a desktop or a laptop computer, it makes it so much easier to develop and integrate with.
Now, I heard you say something, I hear it a lot, obviously working for the company, but you mentioned API. Mm-hmm. Anybody that doesn't know what that is, what is an API?
An API is pretty much just a software library so that any third-party softwares can communicate with this device that you're working with. So Okuma develops their THINC API, and that API makes us able to create our own third-party software and talk to the control directly without having to have some sort of handshake file or text file or something like that. We can just read the macro variables from the machine, the common variables, or adjust the tool data if we need to, which also leads me into another product, a new development product that we're working on is for our presetter line, where we can take our preset data from a presetter and send it directly into the control without needing to manually type it in with the keyboard or going all the way to the route of RFID, bailiff chips, stuff like that. We can just scan a barcode that the presetter generates, and it will save that data from the tool offsets directly into the machine's tool offset table.
Okay.
So that's
nice.
yet another integration that we've kind of worked with for Okuma.
Yeah, fantastic. All right, well, we're running in on our closing time here. So, Jack, people want to learn more about Big Kaiser. What's the best way to go about it?
Well, certainly to contact us on our website, bigkaiser.com, and we're open to any challenge. We can have people come out and see them if that's what they'd like. We like to work with people in their world and what's going on with them, but we're open to all kinds of challenges, whether it's looking for higher accuracy or boring systems or tool presetters. We have a work holding system for quick change that may help some setup reduction. That's all about trying to reduce the amount of spindle hours, and one of those is making sure the spindle's turning. So
right. Fantastic. Yeah. Nick, thank you for joining us.
Yeah,
I really appreciate all the work and the integration you've done on that machine. It looks fantastic.
And there's definitely more to come for sure.
All right, good stuff. So thank you for joining us on this podcast. If you have thoughts, ideas, questions for future podcasts, hit me up on LinkedIn. I'm Wade Anderson on LinkedIn, or you can hit us up on the Okuma.com website. Till then, we'll see you next time.